Good day. In this lecture, we will discuss chemical safety, focusing on hazard identification and warning labels. By the end of this lecture, you should be able to define chemical hazard and identify different warning labels. Chemical safety involves recognizing hazards, communicating risks, and controlling exposure. This is essential in laboratories, industry, and everyday life. A chemical hazard is a substance with the potential to cause illness, injury, fire, explosion, or environmental damage under specific conditions. Under health hazards, these are chemicals that can cause acute or chronic effects after exposure. Examples include carcinogens, irritants, corrosives, neurotoxins, and substances that can damage organs. Under physical hazards, these are chemicals that can cause fire, explosion, violent reaction, and pressure-related accidents. Examples include flammables, oxidizers, explosives, and compressed gases. There are several factors affecting hazard severity. The danger of a chemical depends on the concentration, the physical state such as gas or liquid, the temperature, mixing with other chemicals, storage conditions, and methods of use. So hazard depends not only on identity but also on circumstances. Hazard communication systems ensure workers understand the risk of chemicals they handle. Under OSHA 29, CFR 1910, 1200, and 1983, that is called your right to know law. This includes labels and safety data sheets. A material safety data sheet, now commonly known as safety data sheet, contains hazards, handling instructions, first aid measures, storage requirements, and emergency procedures. In terms of warning labels, chemical labels should include the product name, the hazard warnings, the protective equipment needed, handling instructions, and manufacturer information. Even transferred chemicals in temporary containers must be properly labeled to prevent misuse and accidental exposure. Now let's discuss the chemical hazard types. The first one is flammable and combustible. Flammable are materials that ignite easily. Combustible materials also burn but require higher temperature and stronger ignition sources. Flammables include methanol, acetonitrile, spray adhesive or mounts, and for combustibles that includes diesel fuel and mineral spirits. Next, we have corrosives. These are chemicals that destroy living tissue or damage metals. Examples include acids such as acetic acid and bases such as sodium hydroxide. Others are what we call your photographic fixer. We also have what we call your reactive chemicals. These chemicals may explode, react violently with water, ignite in air, or strongly oxidize other materials. Under this, we have oxidizers, which are materials that react strongly with organic materials, sometimes strongly enough to start fires. An example of which are your nitric acid. We also have your organic peroxides, which form friction and shock-sensitive explosives. An example of which is the benzoyl peroxide and methyl ethyl ketone peroxide. Still under reactive, we have water reactive substances and they react violently with water. An example of which is sodium metal and sodium borohydride. We also have what we call your air reactive or pyrophoric and they react violently with air. Examples of which are silane and tert-butyl lithium. And lastly, we have explosives. These are designed to explode violently. An example of which is TNT or trinitrotoluene and picric acid. We also have acute toxic substances, which are materials that can cause harm to an individual if it enters the body. Under this, we have carcinogens, which are substances or agents that may cause cancer, an example of which is benzene and carbon tetrachloride. We also have mutagen, which are agents that can induce or increase the frequency of mutation in an organism. An example of a mutagen is bromine. Next, we have poison, which are any substance that can impair function, cause structural damage, or otherwise injure the body. Examples of which are sodium azide, powdered pigments, and inks, which may contain toxic metals such as chromium and barium. Under respiratory hazard, we have sensitizers, which are substances that causes hypersensitivity or reactivity to an antigen such as pollen, especially by a second or repeated exposure. An example of which is formaldehyde and phenol. We also have teratogens, which are agents that causes malformation of an embryo or fetus, an example of which is PCBs and mercury. There are two common hazard systems. These two are the NFPA diamond, which rates health, flammability, instability, and special hazard. And we also have GHS pictograms, which uses symbols for standardized global communication. Under NFPA diamond, your hazards can be classified into four. We have health hazard, fire hazard, and reactivity, which are scaled from 0 to 4. We also have specific hazard, which has a chemical or a letter symbol. For GHS pictograms, they are straightforward and the picture shows what happens to the chemical. In terms of personal protective equipment, it includes gloves, goggles, lab coats, and respirators when needed. PPE is the final barrier after proper handling and engineering controls and must be present in the safety datasheet of the chemical. That concludes the lecture on chemical safety. Focus on recognizing hazard, reading labels, and preventing exposure through safe practices.